Hello, welcome back to another video. Now in this one we're going to take a look at area of a trapezium. And this is something that's quite often taught as just a formula that needs to be remembered. And as is usual with my videos, I kind of want to explore the deeper meaning behind these formulas. So what we're going to do is prove that the area of a trapezium is a half a plus b times h, where a and b are the lengths that are parallel, so these two, and h is the height of the trapezium. And we're going to do this using only the fact that the area of a triangle is a half times the base times the height. Okay, so let's get into it. So first, the thing you might be tempted to do is split this into a rectangle and two triangles. And that is exactly what we're going to do. Excellent, now we've got two triangles and a rectangle. So let's call the rectangle R and call the triangles maybe T1 and T2. So we can easily work out the area of R. This is just going to be A times H, because area of rectangle is just length times the width. The length of our rectangle is A and the width is H. Now what we need to do is to work out how long these bits are, because this is the base of the triangle. So let's just call these maybe, I don't know, B1 and B2 for the bases. So what can we see? Well, we can see that this distance in the middle is A, and so if we add up our three lengths across the bottom, so B1 plus A plus B2, we must have B. Okay, and this is really helpful. So now let's try and work out the area of our two triangles. So let's do area of T1. Well, this is a half times B1 times H, and T2 is a half times B2 times H also. So now what we need to do to get to our formula is to add these three areas together. So let's do that. So area of trapezium, maybe I'll call it T for trapezium. So let's add these together. Well, we've got A times H, and we've got the areas T1 and T2. So we've got plus a half B1 times H plus a half B2 times H. Okay, now we remember this little formula here, that B1 plus A plus B2 equals just B, so that's the base of our trapezium, and we go from there. So A times H is still the same, and what have we got here? Well, we've got a half H, and we've got B1 plus B2. Okay, this formula here, well, this tells us that B1 plus B2 equals B minus A. And so we can proceed like this. So this is A times H plus a half H, B minus A. So let's expand this out. So we've got AH plus a half HB minus a half HA. And sort of simplifying these two terms, we get A times H minus a half A times H, so we get a half H A plus B. And that is exactly what we were trying to prove. So there we go, we've proved the area of a trapezium, and we've shown that it's equal to a half H times A plus B, where A and B are the base and top of our trapezium. So I hope you've enjoyed this video. Please leave a like if you did, and comment for any further suggestions. The reason we've done this is because shortly I'm going to take a look at the trapezium rule for integration. So thanks very much. Bye bye.